Get strong.
Hi, I'm glad you are here today. Welcome to my channel. In this video, I'm going to show you how to find the missing angles on the sides of any type of triangle. I will also demonstrate simple techniques using examples on two types of triangles. So let's get started. Alright, let's see this using an example. So the example is actually given to calculate the missing side and angles of a right angle triangle. So we are given the leg AB is 6 units and the base BC is 8 units. We are asked to calculate hypotenuse, let's say AC. So using the Pythagoras theorem, we know AB is given for us, BC is given, so we can calculate AC square. So AC square is equals to AB is actually 6 square plus BC is 8 square. So that means 6 square is 36 plus 8 square is 64, and so it gives us 100. So as you know, AC square is 100, then AC will be square root of 100, which is 10 units. So our hypotenuse is 10 units. Alright, how do we find angle alpha? So here we are going to use trigonometric functions, which is sine, cosine, and tangent. At least we can use sine and cosine functions to calculate the missing angle alpha and theta. So as you know, in a right angle triangle, the two sides of a triangle make 90 degrees. Therefore, because we already have 90 degrees here, the rest of angles must sum up to 90 degrees. So that means what's alpha and what's theta? That means alpha and theta, they are 90 degrees. We know this equation. The other is, in the right angle triangle, line of angle theta must be equals to opposite side of this angle, which is AB divided by hypotenuse, AC. Alright, next, let's calculate angle alpha and theta. So we're going to use trigonometric functions to find angle alpha and theta. Okay, let's find angle alpha. That means this angle alpha is can be calculated using, let's say, sine of angle alpha must be equals to the opposite side of angle alpha, which is BC, divided by hypotenuse, which is AC. Alright, so we have BC. We know BC is given, which is 8 units, divided by hypotenuse, which is 10. That means 0.8. Then what this 0.8 means? So alpha is actually, let's use another the next section. Let's do this one. Alpha is equals to sine inverse of 0.8. So whenever we are doing trigonometric functions, we need to convert radians into angles. So this is in terms of angle in degree, but this is in radians. So we have to use some sort of tables to convert the radian into an angle. So to convert a radian into an angle, we have to always inverse the trigonometric function. Okay, let's see from the table what's the value of 0.8 radian in terms of sine angle. Okay, let's find the value of angle alpha from trigonometric tables. So this kind of trigonometric tables are actually found in any mathematics books or textbooks. So I'm looking for sine inverse of 0.8 value, which is, I can see it here, right here, 0.8. So the 0.8 value here means, okay, I'm gonna write this. So that is right here, 0.8. That's 0.8, or to be more specific, you can use this value as 0.7986, which is 53, angle 53. So we can take alpha as angle 53. Alright, from trigonometric table, sine inverse of 0.8 is 53 degree. Okay. We can also find the same angle 53 using cosine law, or the cosine function, which means, let's use this, cosine of the same angle alpha. Cosine of the same angle alpha means adjacent of this angle. So adjacent of this angle is AB divided by hypotenuse, which is AC. Okay. So that gives us AB is 6 units and AC is 10 units. That means 0.6. So angle alpha is cos inverse of 0.6. So we can use the same table and then find 0.6 radian of the cosine inverse angle. So that gives us exactly the same value of 53. Okay, let's go back to the table and then search for radian 0.6 for cosine inverse. Or for cosine angle, it's right here, 0.6. So 0.6 is still 53. So this is pretty much the same. You can use either sine function or cosine function. They should always give you the same. Alright, so the cosine inverse of 0.6 is exactly the same like this and the previous angle, 53. Okay, so we have calculated the angle alpha value using cosine and sine functions. Then what would be the last angle, which is angle theta? Alright, the third angle theta can be calculated either using the same trigonometric functions, sine or cosine, or we can directly calculate from the rule of the summation of the internal angles of a triangle must be 180 degrees. Okay, let's use that as a simple method to calculate the last angle theta. So we know that the internal angles such as alpha plus theta plus the right angle 90 degrees must be altogether 180 degrees. And also alpha plus theta must be 90 degrees, which is 180 degrees minus 90 degrees. That gives us 90 degrees. So we know alpha, we calculate it as 53. So we can check that value in here, 53 degree plus theta is equals to 90 degrees. That means theta is 90 degrees minus 53 degrees. Okay, that gives us this is not exactly. So this is 53 degree. It must be 37 degree. So theta is 37 degree. So this is generally how to calculate the missing sides and angles of a right angle triangle. The second method is we're going to use actually, alright, the second type of triangle that we are going to see today is a Scalene obtuse angle triangle. So these are two different concepts. A Scalene is actually, it's a type of triangle where all the three sides are different sides. An obtuse angle is actually, it's an angle one of whose angles is greater than 90 degree. Let's say this alpha is 120 degree. Okay, from the rule of the internal angle summation of 180 degree, we can conclude that the rest of the two angles, which is theta and beta, must be 60 degree. So theta and beta are 60 degree, and we have 120 degree, which is alpha. So altogether they sum up to 180 degree. Okay, that's one concept. So for any triangle other than the right angle triangle, the missing sides, any of missing sides and angles can be calculated using the trigonometric functions, which are called law of cosines and the law of sines. Okay, we will see this in detail. Alright, so let's assume this triangle has got the shortest side AB, which is given as unit 4, and then side AC is 6 units. We are asked to determine side BC, which is the longest side. Okay, for an obtuse angle, the side facing to the largest angle is always the longest side. So BC is the longest side, which is facing to the largest side angle, sorry. Okay, so let's calculate the value of side BC and the remaining angles theta and beta using the cosine functions. Okay, what is the sine or cosine law? Alright, the first trigonometric function that we are going to use to calculate the missing sides and angles of an obtuse angle triangle is the law of cosines, or it's cosine law, cosine rule in short. So it says that the sides of a triangle, which is not the right angle triangle, should satisfy the condition that the sum of the squares of any two sides is less than the square of the third side. Alright, so we are asked to determine BC. So BC square must be equals to AB square plus AC square, sorry, minus 2 times AB times AC cosine of alpha in general, or 100 cosine of alpha, let's say. So according to the law of cosines, what it states is that the square of the longest side BC must be equals to the square of the shortest side plus the square of the other side minus 2 times the shortest side times on the other side times cosine of the included angle between the shortest and the other side. Okay, that's the general definition of cosine law. So I think it's very important to know how to remember this law of cosine. Okay, so this is, if you consider this section, only this part, it's a Pythagoras theorem. So it's a Pythagoras theorem. So we have added this section, just this part. So it's a negative, which means it's less than this unit. So that's why it says the square of the sum of the squares of any two sides is less than the square of the third side. So the sum of the squares of any two sides is less than the square of the third side by this amount of value. So that is the law of cosine. So we have Pythagoras theorem, and then from Pythagoras theorem we have this part just to add up into our law of cosine or cosine rule. So we can simply remember using these two concepts. All right, so that's one way to remember the law of cosines. Let's calculate the side BC using the given values of the two sides and one angle. All right. Okay, BC square is equals to AB is 4 square plus AC is 6 square minus 2 times 4 times 6, because AC is 6, AB is 4, times cosine of 120 degree. Okay, so this is 16 plus 36 minus 2 times 4 times 6 is 48 times cosine of 120 degrees actually minus 0.5. So we can find this value from table, the one which I've showed you earlier. So from that table, directly checking the value of 120 degree for cosine, it gives us minus 0.5. So this means in general, so that is 52 minus, and minus is plus. Half of 48 is 24. So that means 76. So BC square is equals to 76, which means BC is the square root of 76. Alright, so that value gives us around 8.7. So our BC is it's 8.7, which is the longest side of this Scalene triangle. Okay. Alright, this is the cosine law. How do we calculate the other angles theta and beta? So in this case, we're going to use the law of sines to calculate angle theta and beta. So the law of sines states that side AB or sine of angle theta divided by the opposite side, which is AC, must be equals to sine of angle beta divided by the opposite side, which is AB, and this must be equals to sine of angle 120 degree divided by the opposite side, which is BC. Alright, in this case, actually, we know side AC, side AB, and side BC, and also sine of 120 degrees known. Alright, let's calculate sine theta first. So that means sine theta divided by AC must be equals to sine beta divided by AB is equals to sine 120 degree divided by BC. Okay, so that means sine theta divided by AC must be equals to sine 120 degree divided by BC. Okay, sine of 120 degree divided by BC. Okay, so sine theta divided by AC is actually it's 6 units is equals to sine 120 degrees actually square root of 3 divided by 2. That's something that we can find it from trigonometric table, divided by side BC, which is 8.7. So we have calculated this value earlier. So when we crisscross this equation, when we crisscross multiply this equation, what we find is sine of theta multiplied by 8.7, which is 8.7 times sine of theta must be equals to, so 6 times root 3 over 2. 6 times square root of 3 over 2. Alright, so let's go this and calculate the value. So this is 1 by 2, which is 3. Alright, then this is this space. So sine of theta 8.7 times sine of theta must be equals to 3 times square root of 3. Okay. Alright, let's move this a little bit to the side. So multiplying both sides by 1 over 8.7, what means 1 over 8.7 multiplied by 8.7. Alright, dividing both sides by 8.7, we will have 8.7 divided by 8.7 as well. So that means this cancel each other, and sine of theta is equals to 3 times square root of 3 divided by 8.7. So probably we need to have calculator. So calculating this value, we will find 0.398. Alright, that means to convert this radian value into angles, we need to inverse the sine function. So theta must be equals to sine inverse of 0.398. So We'll go to the table and then find what's the value of 398. Okay. Alright, from the table that we have here is, we can read this value. This is sine value, this is cosine, this is tangent. These are all our angle values. So we go to 0.398. Let's go to all the way down and find 0.398 is between somewhere these two values. So we can take angle 23. Alright, that would be our angle. Theta is equal to 23 degree. Alright, so previously what we have said is actually angle theta and beta must be 60 degree, because we already got an obtuse angle which is 120 degree. So theta and beta must be 60 degree. So from this, what we'll have is actually theta plus beta must be 60 degree. So that means from this, beta will be 60 degree minus theta. So beta is 60 degree minus 23 degree, and beta is equal to 37 degree. Okay, so that's the value of angle beta. And so in general, for any non-right angle triangle, we can use the rule of sine and cosine to calculate any missing angles and sines of any triangle. All right, thank you for your time. Please, if you find this video helpful for you, just subscribe to my channel, and thank you for your time. Bye.